So we're living in this incredible time where AI can actually listen, right? It transcribes our meetings, it takes our voice commands, it can even figure out the emotion in our voice. But as these new AI assistants get smarter and smarter, there's this huge kind of hidden challenge that's popped up.
I mean, really think about that for a second. Just because an AI can turn your speech into text, does that really mean it gets the meaning, the nuance, the real intent behind what you said? That's the core question developers are wrestling with right now. And believe me, the answer is way more complicated than you'd think.
All right, so to really get into this, we need to talk about a new kind of AI. They're called Large Audio Language Models, or LLaMs for short. These are the powerful engines running the latest voice assistants, and they go way beyond just text. We're talking about processing everything from spoken words to the ambient sounds of a busy street. But the real question is, how do we know if they're any good?
To figure that out, well, you have to test them. It's kind of like how a person takes a hearing test, right? These super advanced AIs need to be put through their paces so we can see what they can and can't actually comprehend. But there's a problem, a really big one actually.
As it turns out, the very tools we've been using to test these AIs are, frankly, broken. Researchers have pinpointed 3 massive bottlenecks that are seriously holding back the entire field of audio AI.
So it all comes down to this super simple idea. You can't improve what you can't measure. I mean, imagine you're trying to build the fastest race car in the world, but your stopwatch is slow and totally unreliable. You'd have no idea if your changes were actually working. Well, that's pretty much the exact spot AI developers have been in.
And here they are, those 3 core problems laid right out. First off, the old evaluation tools are painfully slow, like they create a massive traffic jam for research. Second, they're wildly inconsistent. Different tests ask questions in different ways, which makes it impossible to compare models fairly. It's like giving students totally different versions of the same exam. And third, the tests are just too simple. They don't check for the complex stuff we actually care about, like can the AI reason, or can it understand the timing of a conversation?
And this chart just visualizes that first bottleneck perfectly: speed. What we're looking at is something called the real-time factor. Basically, how many times slower these tests are than the actual audio they're trying to analyze. Look at VoiceBench over on the right. It takes almost 88 hours to process just 1 hour of audio. That's not a bottleneck, it's a total brick wall.
But now, finally, a new solution has come along to just smash through that wall. It's a new open source toolkit called AU Harness, and it was literally built from the ground up to fix these exact problems.
So how does it do it? Well, it's pretty smart actually. It takes on each of those 3 bottlenecks head on. For the speed problem, it uses a super efficient engine that can process stuff in big batches. For the consistency problem, it creates one unified system that standardizes all the questions, making it a level playing field. And for the scope problem, it adds brand new, way more difficult tests that really dig into a deeper level of understanding.
Of course, it's one thing to say you've fixed the problem, but it's another thing entirely to prove it. So researchers put AU Harness to the test, and the results were, well, pretty dramatic.
Get this, a speed up to 127%. That single number is a gigantic leap in efficiency. It basically makes large-scale systematic AI testing actually practical for the first time ever.
And this shows you exactly what that means in practice. We're looking at samples processed per second, so here, higher is better. The best of the old toolkits just kind of chugs along at 1.87 samples. AU Harness nearly doubles that. It's the difference between using that old, unreliable stopwatch and a cutting-edge laser timer.
But here's the thing. As amazing as that speed is, it's only half the story. The real game changer here isn't just about evaluating AI faster. It's about evaluating it smarter. It's about finally asking the kinds of questions that reveal what an AI truly gets.
This table lays it all out so clearly. The old tests? Yeah, they were fine for basic speech recognition. But look at those bottom 2 rows: LLM adaptive diarization and spoken language reasoning. The old toolkits had a total blind spot there, and that's exactly what AU Harness brings to the table.
So, what on earth is spoken language reasoning? Well, it's the ability to think and come up with new conclusions based on just audio. For instance, can an AI listen to you say, "Hey, build me a database of my customers," and then actually generate the correct computer code to do it? That's a whole other level of understanding.
And what about that other one, LLM adaptive diarization? This is another huge leap. This is all about testing whether an AI can follow a real conversation and figure out who said what and when. It's about understanding the flow, the back and forth of human speech, a skill that is absolutely essential for any voice assistant to be useful.
Okay, so now we have this powerful new lens to look at AI with. What did we actually learn? Well, these smarter, faster tests have revealed some really fascinating and, frankly, critical insights into the minds of today's audio AIs.
This quote from the researchers really just sums it all up. For the first time, they could actually pinpoint these significant gaps in what an AI can do, specifically when it comes to understanding timing and complex reasoning. The AIs were basically failing the parts of the test they'd never even been given before.
And check this out. This might be one of the most surprising discoveries. It's called the instruction modality gap. Turns out, AIs are way better at following written instructions than they are at following the exact same instructions when they're spoken out loud. I mean, performance can drop by a massive 9.5 points. It really suggests there's a huge difference between just reading and truly listening.
So let's just boil this all down. What are the key takeaways here? First, better tools lead to better AI, period. You just can't fix the flaws that you can't find. Second, we now have hard proof that there's a real gap between just hearing words and actually understanding them. And finally, the next great challenge for audio AI is crystal clear. It's mastering complex reasoning and the tricky timing of human conversation.
Which leaves us with this one last crucial question. As these AI models become a bigger and bigger part of our lives, constantly listening and talking with us, the challenge isn't just about making their hearing more accurate. It's about ensuring that when they listen, they're truly, genuinely starting to understand.